Good morning everyone. Welcome to the Gurukulplex presentation on understanding Newton's laws and the power of motion. In this presentation, we will explore the impact of Sir Isaac Newton on the scientific world and on modern physics. We will investigate his three laws of motion, his contributions to the study of light and optics, and his development of calculus and the laws of gravitation. Come and join us as we explore the captivating world of Isaac Newton and the remarkable power of motion. Everyone, I'm here to explain the significance of Newton's laws of motion. We'll take a journey into physics and understand just how powerful motion can be, from the minutest particles to the largest celestial bodies. Knowing these laws helps us design more efficient spacecraft and analyze the human body more effectively. We'll gain better insights into the world around us and challenge the limits of the foreseeable future. Let's begin. Sir Isaac Newton was a brilliant physicist and mathematician who lived in England in the 17th century. He is renowned for his three laws of motion and his studies of light and optics, which created the basis for modern physics and set the stage for numerous modern scientific studies. His laws of gravitation clarified the conduct of celestial objects, and his work on calculus was a remarkable breakthrough in mathematics. Notwithstanding being centuries old, Sir Isaac Newton's contributions are still being studied and utilized by today's scientists. An object at rest will remain at rest, and an object in motion will remain in motion with a constant velocity unless acted upon by an external force. This is Newton's first law of motion. To illustrate, if you put a book on a table, it will stay there unless you push it or take it off, and a ball rolling on a flat surface will continue rolling in the same direction with the same speed until something like friction or another external force stops it. To summarize, Newton's first law of motion states that objects maintain their motion unless an external force changes it. Newton's second law of motion describes the relationship between acceleration, mass and force, stating that force applied to an object is directly proportional to the object's mass and acceleration. This means that a greater force will result in a greater acceleration. Alternatively, a greater mass will cause a decrease in acceleration when the same force is applied. For example, by applying the same force to two objects of different masses, we can observe that the bigger object will move slower than the smaller one. This law is essential for understanding how objects move and interact with each other. Newton's third law of motion, also known as the law of action and reaction, is evident in many aspects of life. For example, when a person pushes off a diving board, the board exerts an equal and opposite force that pushes them into the air. This same force can also be seen in the swing of a bat, the recoil of a gun, the thrust of a rocket, and the motion of bicycle pedals. By understanding this law of motion, we can better understand the power of motion. Newton's laws of motion are fundamental to our understanding of motion and its effects. These laws allow us to observe and study the movement of objects, and to apply this knowledge to the design and development of engineering breakthroughs. Through the application of these laws, we are able to construct vehicles, airplanes, and space shuttles that can travel faster, safer, and more efficiently. Furthermore, Newton's laws are key to understanding the behavior of objects in motion, such as projectiles and satellites, and to predicting and controlling their trajectories. Motion is a powerful force, and it is incredible how much insight we can gain by studying it using the laws of motion. Newton's laws of motion play a critical role in our understanding of the physical world and its many applications. From the construction of bridges and skyscrapers to the development of transportation technologies, mastering these laws is essential. But their usefulness is not limited to these fields. They can also be applied to sports, allowing athletes to refine their skills and maximize their performance. In conclusion, knowledge of these laws is essential for anyone looking to make advancements in science, engineering, or sports. Newton's laws of motion have been called into question by quantum mechanics and relativity. Quantum mechanics explains the actions of particles and relativity looks at the effect of gravity on motion. In the following discussion, we will look at how strategic planning can aid businesses in lowering expenses and elevating profits. We are currently on the 10th slide of our presentation, which focuses on Newton's laws of motion and the power of motion. These laws are deceptively simple yet incredibly powerful in how they explain the way objects behave when in motion. The first law states that an object at rest stays at rest and an object in motion stays in motion with a constant velocity unless acted upon by an external force. The second law states that the acceleration of an object is directly proportional to the net force acting upon it and inversely proportional to its mass. The third law states that for every action, there is an equal and opposite reaction. Their applications range from physics and engineering to exploration and transportation, allowing us to better understand the world around us and how it works. Newton's laws of motion are some of the most fundamental laws of physics, and it is important to understand any misconceptions about them. One misconception is that they only apply to objects at rest or in uniform motion, when in fact they are applicable to any object regardless of their speed or direction. Another misconception is that the laws only apply to large objects, when in fact they apply to any size object. Finally, many people mistakenly think that these laws only apply to Earth, when in fact they are universal and apply to any object in the universe, including those in outer space. We have come to understand the impact of Sir Isaac Newton's laws of motion after learning about his life and work. These laws provide the foundation for many practical applications from engineering to transportation. But the power of motion can even go further. It can help us build a deeper understanding of the universe. Newton's laws challenge us to question our assumptions, seek out new knowledge and unlock a greater understanding of the world around us. Thank you for listening.